Hi, I'm here to give an update about our news aggregation project. Um, as motivated by this blog post, um, every day different news sources report the same stories, and then for a reader, uh, they have to decide whether they've read the story or not. So we want to build a pipeline to aggregate this information, and for each unique story, produce only one article for the user to read. Now we see that here, this blog post um, implemented a naive approach where it uh, substituted um, each token in the article with their corresponding word vectors and just averaged them. And then they ran a clustering algorithm. So the downside of this algorithm is that first you have to decide how many clusters you want to cluster into, or at least you have to set a threshold, and this can be very, very inaccurate depending on how many unique stories are from all the sources. Secondly, um, if two article titles or description um, share a lot of the same tokens, for example, they have the same people involved, but in two different events, then this algorithm, this particular approach, might still cluster them together. And to counteract this, we decided that we want to have a news classification system prior to the clustering step to help reduce these kind of errors. Um, so the idea is that for a news for a person, they can be involved in two news stories, but if they are um, different kind of news, and then we can classify them to be different kind of news, then we don't run the clustering algorithm on those two articles. So we would run the clustering algorithms individually in each news category. We are using the tag my news data sets here that we see that each uh, sample has a title and a description, which is what we care about, and a category, which is labeled to be one of the 7 categories um, in this data set. Uh, and in our pipeline, we first read in the articles, and as you can see, this is the count of the articles. We then uh, converted them by turning them into a count matrix, and then doing a TF-IDF transformation. Um, Nextly, we did a train test split, and then we ran three different models. So the first model is the naive Bayes model, and here is the output. The training is relatively fast, and we see that the results are somewhat promising in some categories. For example, in sport, the F1 score is pretty high. The recall is pretty high. We see that in categories of science and technology, the scores are still pretty low. Next, we ran a softmax, just a simple one-layer neural network with hidden layer size 100, and then uh, the training took a very long time, about an hour, and then we see that the scores don't really improve. In fact, it's worse in some case, but uh, we see they are more consistent around precision recall and F1 score. Specifically, we see that here the science technology section increased a lot. And then lastly, we also ran a SVM. And then for the SVM, the performance seems to be better. Um, and then these are the three preliminary models that we used. Um, and and here we have, I guess, a code section that we can play around with. So when we're doing the error analysis for now, for example, we see that this is using the news API. to get the top stories right now, headlines, and then we pick a random article and then we try to classify it. For example, we see this is a article. Uh, when we concatenate the headline and the description, we see that it's roughly telling us about the earnings estimate, like how Zoom is doing, and then we classify this as business, which is what we want. But we also see mistakes. For example, here we see that uh, the White House is doing something. So this is obviously probably, if there's a category called politics, it will be in politics, but it certainly isn't sport. But probably what happened is that we see a lot of words like position, like moving, probably. So forward. So these might be indications of like like actions in sports, and that could be what gave us the wrong prediction. So there are several ways we are thinking of improving our model. First is that we want to do some text cleaning beforehand. So right now, we weren't doing much cleaning, such as removing punctuation. So some of the tokens might be still attached to the punctuation if they're at the end of the sentence, for example, and these might influence the results. Also, we are not really utilizing pre-trained word vectors or even there are even like models such as sentence to vector. So we can imagine that if we implemented a sentence to vector model and then transform the title and description concatenate together into a vector for the softmax classifier to classify, then this will be much better because the softmax classifier only has one layers, and it might be hard to learn representations, without a much deeper model. Also, we found this data set, also a news category data set on this web, and it has 200,000 records, so it has much more data than what we have right now. But the problem is they're only from this one source, the Huffington Post. So we are not sure if we want to incorporate this data into training, but uh, uh, we can always try and then see if it improves or not. And um, that's about it for now. So what we will do next is improve our models and then maybe augment this section of testing with real-time news, and then add in the clustering algorithm from the blog post and see how we do. We are a little bit confused about how to evaluate our final output in this step, because the previous step it's very easy to see the precision recall F1 score, but in this step, like judging how well it clusters real-time news, that is relatively hard. So we are just planning to use human judgment on this part. And thank you for watching.